Hello students, I am Raghuraj Singh, Assistant Professor in Computer Science Department, Ajay Kumar Garg Engineering College, Ghaziabad. So, in continuation to previous lectures, lecture 1 on machine learning techniques, the topic is decision tree. So, I am continuing just previous lectures, lecture 1 that I have given lecture about the decision tree. So, while talking about the decision tree, so what the decision tree? Decision tree learning is one of the most widely used method for inductive learning. So for the inductive purpose of the learning, we basically employ the concept of the decision tree. So decision tree is basically one of the most widely used method that is used in the case of the inductive learning. It is a method of approximating discrete valued function that is robust to noisy data. So basically, if we have the noisy data, for that particular set of data, we can employ the technique that is called the discrete decision tree learning. So basically, decision tree learning is a basically method of approximating the discrete valued function that is robust to noisy data. So it is applicable for employing the decisions for the noisy data. That's why you use the decision tree. Decision tree is basically supervised learning method. Basically, we have the three type of learning in case of the machine learning. So decision tree is basically a supervised learning technique. Another techniques are unsupervised learning and reinforcement learning. So out of these three learning techniques, basically decision tree is a supervised learning technique where the data is continuously split on the basis of certain parameters. So in case of the decision tree, we make the decision tree, which is just like a data a tree like data structures. So if we have the tree like data structure, that is called the decision tree. So tree is formed on the basis of certain parameter. So these parameters work as the decision to provide the decision and to split the tree in the different branches. So basically, if we have the this particular kind of nodes, that is called the parent node. So if we have the parent node, then after that we based on some decision, we will again split this particular root node into sub node. So this particular sub node are called as leaf node for this root node, and this is at this particular point of time the decision S, there should be decision like S, or decision should be no. So according to value of yes or no, whatever should be the logic, what should be the mathematical background should be there. So according to that background, we will take the decision. If decision is yes, then it will further will be sub branch will be created, that will be defined as the leaf node. If further these nodes are classified, then again it will be called as the parent node for this leaf node. So already I have discussed what is the parent node, what is the leaf node. So parent node are the node from which the decision tree starts. So that is called the parent node. And what is the leaf node? Leaf node is nothing, but this is the final outcome of the decision, and leaf node does not have further classification, does not have further sub branching. That is called the leaf node. So decision tree is basically a supervised learning technique where the data is continuously split on the basis of certain parameter based on the certain decision parameter. So decision tree is basically nothing. This is that works as a classifier which classifies the stands by sorting them down the tree from root node to the leaf node. So from root node to the leaf node, it performs the classification where the different data stands are classified into the parent node, into the sub parent node, into the leaf node, according to the value of according to having their mathematical value, according to the decision performed from root node to the sub node, from sub node to the leaf node. So decision tree is basically a classifier that works as a classifier, which is in which stands are sorted from root node to the leaf node, that is basically from top to bottom, from root node to leaf node. So decision tree comprises of two type of nodes, decision node and leaf node. So that we have already discussed. So how decisions should be performed? Decision node should be at here, that like this is a particular node, where the test is performed. Basically here at this particular node test is performed, accordingly we take the decision. If decision is yes, then this particular node will be created. If decision is no, then this particular node will be created here. So decision node specifies a choice or test based on which we decide whether what action need to be performed, what decision need to be taken. So accordingly the further sub branching should be done in the case of the tree, decision tree. So what is leaf node? They indicates the classification of the example or the value of the examples, and which doesn't have further classification, that can be defined as the leaf node. Decision tree can be used to treat both classification and regression problem. So basically decision tree can be utilized for both classification and regression problem, but mostly it can be used for the classification problem, but it is also not limited to the classification purpose only. So a regression problem can be also solved with the help of the decision tree, in which we predict the continuous quantity, that is that can have some kind of real values. Oh, and in the case of classification we have discrete output value, that is can be defined as yes or no, red or blue, like positive and negative. This kind of the binary parameter, binary decisions can be given out with the help of the classification task. So we will discuss basically what is the logic of decision tree working, how decision tree works, and what is the logic behind working of the decision tree. So decision tree starts with the root node of the tree. Based on the value of the test, you move to the corresponding branch, and this process continue until you reach the leaf node. So in case of the decision tree, first of all we starts from the root node. Root node is defined as this way. So in the very first node should be root node, on which decision or test will be performed. Decision or test will be performed. So on the basis of decision or test, it has the further classification. So it will be classified in again at the sub branching should be there. If there is again some kind of the test, then again test will be performed, then again there is further classification of the tree, again decision or test will be performed, so again there should be classification of the tree. So if there is no further branching, so this will be said to be as the leaf node, and this leaf node doesn't have any further classification, that's why it is called the leaf node. So decision tree can be used to treat both classification and regression problem, as we said. So decision tree starts with the root node of the tree. So we start from the here, that is called the start node, that can be defined as start node. So we start from the root node of the tree. Based on the value of the test, whatever the test will be performed at here, we will move towards the downward toward the value of the test. You move to the corresponding branch. We are moving to this corresponding branch according to the value of the test. That if it is yes, then we'll be move into this branch. If it is no, then we'll move on to this branch. Then again decision or test will be performed on next sub branches. If it is again performed some decision or test, then again there should be division. So splitting should be again there. So if we have splitting, then again sub branch will be created. If it again is decision is yes or no, then again sub branch will be created. So we will move to the corresponding branch, and this process continue until you reach to the leaf node. So if we have leaf node and there is no further classification, then it is said to be that or decision tree has been created. So for example, that how we will create the decision tree, how the decision tree is created. For that purpose, I have taken a simple examples that could be a real life examples. So first of all, this particular problem is associated that designing a decision tree for whether loan should be approved or not. So if some customer has applied for loan into the in some bank, so bank how will the bank will decide, how the bank will decide that whether this particular applicant loan will be provided, loan will be approved or rejected. So in order to take the decision, we can employ the decision tree. So first of all, if application goes to the bank will verify whether this particular person who have given for the loan application for the loan, whether the particular person is employed or not. if the person is employed, then bank will also check that what is the income of that particular applicant. If income is high, then loan will be approved. If income is very low, then loan will be rejected. So again, if the person is not employed, then again we will see what is the credit score of the particular applicant. If the credit score is very high, that means that particular person having some another form of source of earning. So if he or she having the high credit score, means they are earning the money, that credit score is very high, that means the loan should be approved. Otherwise, if the credit score is very low, then loan applications will be rejected here. So this is the particular scenario, this is the particular case where the concept of decision tree will be applied, where we apply the concept of the decision tree. So this is the approach where we can approve whether loan should be approved or not. So this particular scenario has been described with the help of this particular decision tree. So this is the way that how the decision tree takes the decision on the certain nodes. So this is the root node, this is the sub root node, then this is the again sub node, then again A and R are the leaf node, A and R are again the leaf node. So in this way, this decision tree should be created. So we will see that what is the appropriate problem for decision tree learning. So we can apply the decision tree where strengths are represented by attribute value pairs. So if we have the two different value, so what value should be chosen at which conditions, that can be easily described with the help of the decision tree. So strengths, if strengths are represented by attribute value pairs, like attribute are value 0 and 1. So in which conditions it will take the value 0, in which condition it will take the value 1. So if it is condition is no, the value should be taken 0. If decision is yes, then value will be taken as 1. So this kind of decisions will be performed in the case of the decision tree. To perform this kind of decision, we apply the decision tree. So problem in which training statement contain missing attributes, the training statement contains the missing attributes. To classify that, we can use the decision tree. If training data contain errors, then we can also apply for the decision tree. So this is the particular point where we can apply the decision tree to solve the problems. So there are the 4 different type of situations where we apply the decision tree. So what are the strength and weakness of the decision tree? Decision tree are able to generate understandable rules. Decision tree perform classification without requiring much computations. So because the basic concept of basic approach of the decision tree is basically based on the human approach, that in certain situations how the human being take the decisions. So that kind of human thinking is also involved in the case of decision tree. So that's why decision tree doesn't decision tree perform classification without requiring the much computation, and are able to handle both continuous and categorical variables. So decision tree, as we have in previous slide I have already discussed, that decision tree can be employed for classification as well as regression task. So major use of decision tree is in case of the classification, but we can also employ that for regression problem also. So in order to predict the handle the continuous value, we can also use the decision tree. And if we have the categorical variables like binary variables, binary outcome, so for that purpose we can obviously apply the use of the decision tree. So decision tree provide a clear indication of which fields are most important for prediction or classification. So if we are applying the decision tree, so decision tree basically provides the clear indication, clear remark over the things that which fields are the most important for the prediction or classification. So most important things will be selected for the classification or regression task, and that can be chosen as the root node or leaf node according to their value of the proximity. So we will also talk about the how the most important attributes will be selected. So that is based on the information gain. So we will see in the subsequent lectures in this next slides. So decision tree are prone to errors in classification problem with many class and relatively small number of training examples. So these are the some strength and weakness of decision tree. So what is the decision tree learning algorithm? So ID3 is one of the common decision tree learning algorithm. ID3 is one of the common decision tree learning algorithm. So where ID3 is acronym of iterative dichotomizer. So here iterative dichotomizer means dividing into two completely opposite things. So obviously in the case of the decision tree learning, we split the data into two branches, into two or more than two branches. So that's why the algorithm iteratively divides attributes into two things. So that's why the algorithm divides into the two different things, because the splitting is carried out on the decision node, and it can be the root node, it can be the sub node, sub root node of the root node. So iterative dichotomizer clearly indicates that the splitting or division of the into two sub branches. So that is called the dichotomizer. So dichotomizer means is basically dividing into two completely opposite things. So that's why the algorithm iteratively divides attributes into two things. And the concept of decision tree learning algorithm, this ID3 algorithm was introduced in the year of 1986. Decision tree learning algorithm transform raw data into rule based decision making tree. So obviously in the case of the decision tree learning algorithm, we classify the data, we classify the split the nodes according to some decision rule, according to some certain parameters. So this parameter is called the rule based decision, So that's why since decision tree learning algorithm employs the decision tree decision based decision rule based decision process, that's why it is also called as the rule based decision making tree. So ID3 builds the decision tree in top down approach. In case of the construction, while construction of the decision tree, we employ the concept of the top down approach, while there is also the bottom up approach is also there. So if we move from root node to the leaf node, from top to bottom, so that is called the downward approach. So this is the approach that is used from root node to the subsequent node. So that's why it is called as build the decision tree and top down approach. So this particular process is called the top down approach, because we are moving from top to bottom. So that's why it is also called as top down approach. So this process, if we are moving from root node to the leaf node, and from this particular node to again further sub branching is there. So this will be called as root node, this will be called as leaf node. So we are moving from root node to the leaf node, that's why it is called as top down approach. Since we are moving from top to bottom, that's why it is called as top down approach. So ID3 build the decision tree in top down approach with the question which attribute to be tested at the root node. So this is the particular things that matters in the case of the decision tree, that which attribute to be tested at the root node, which attributes will be selected for the root node. So that will be also see here. So best attribute is selected and used as the test at the root node of the tree. So whatever the will be the best attribute, that best attribute will be considered for the root node of the tree, and descendant of the root node is then created for each possible value of this attribute. So the particular values associated with that attribute which has been selected for the root node, that will be considered for the descendant of the root node, and the training examples are sorted to the appropriate descendant node. So accordingly the training examples will be sorted for the next level of the descendant node. So the entire process is then repeated using the training examples associated with each descendant node to select the best attribute to test at the point in the tree. So accordingly we will at each and every level of the decision tree, we will always select the best attribute that will be suitable for the creation of the decision tree. So now while designing a decision tree, now there is a question that while designing a decision tree, while creating the or constructing the decision tree, there are two decisions that need to be made. The first one is that when to stop. So when to we will stop the creation of the decision tree, when we will stop the splitting of the nodes in the decision tree. So there are two basic fundamental point that matters for the when we need to stop the splitting of the decision tree or creation of the decision tree. that is first point is that no more, if no more input features are available, if there is no further more attributes, no input features are available, in that case we will stop the creation of the decision tree, we will stop the splitting of the decision tree. And if all training examples are already classified, if all training examples are already classified, then in that case we will stop the creation of the decision tree, we will stop the splitting of the decision tree. So this is the one of the most point that we need to know while creation of the decision tree. So again next point is based on that which test to split on. So which particular decision need to be split on, when we need to split the particular decision. So split that gives the small error. So we need to split that node that gives the small errors, split that divides the value into 1 by 2. So we will divide the those attribute, that attribute which divides the attribute into 50-50% of in half ratio. So we'll take these 2 points as a particular information while creation of the decision tree. So to decide on these 2 particular decision, we measure some statistical quantity, and statistical quantity is defined as gain. So gain is basically to, in order to calculate the gain, we need to create the entropy of the information, entropy of the data sets. So again, so first of all we create calculate the entropy. Entropy is defined as I summation I is equal to 1 to n RC minus pi log pi base 2. Then again, if we have calculated the entropy of the data sets, then we can find out the information gain, that is defined as gain of SA. That means S is here, S is the data set, A is the attribute with respect to that particular data set, that is called the that means we are creating the, we are getting the gain ratio, gain information gain of the attribute A in data set S. So that it can be defined as entropy of S minus V belongs to value of A mod of SV divided by mod of S into entropy of SV. So this is the formula for calculating the information gain of a attribute in the case of the decision tree. So there are 2 particular cases where attribute is the with that to decide which attribute is the best classifier. In order to decide that which attribute is the best classifier, there are 2 cases. One is central choice of in ID3 algorithm is to select the which attribute to test at each node. So which attribute we selected for the root node. So in order to identify this, we consider a statistical property that is called the information gain. So in order to calculate the information gain, we need to calculate the entropy first. So entropy can be defined as, what is entropy? In order to define information gain, we define a statistical quantity that is called the entropy. So entropy is defined as the impurity of an arbitrary collection of example. Basically entropy defines the impurity of the collection of examples, or impurity in the collection of data sets. So let's say there is collection S which containing the impurity. So some that can be measured as entropy of S is equal to minus P positive log P positive negative base 2 minus P negative log P negative base 2. So this is the formula for considering the one positive and negative values. So we will again we can, if we have the calculated the entropy of the attributes, then we can calculate the information gain. That is simply expected information gain is basically simply the expected reduction in entropy caused by partitioning the examples according to this attribute. So basically that defines the expected reduction in entropy, that is called the information gain. The so more precisely, the information gain that can be defined as gain of SA, that means in data set S, attribute A, information gain of attribute A related to the collection of example S is defined as gain SA is equal to entropy of S minus V belong to values of A mod of SV upon S, entropy of SV. So gain SA is the expected reduction in entropy caused by the value of attribute A, and again it can be defined as gain SA is the information value provided by about the target function value given the value of some other attribute A. So this is the way that how we can select the particular attribute, that whether which particular attribute is the most important, which is the best one to decide to take as the root node. So if the particular attribute having the highest information gain, then that particular attribute will be selected as the root node. So inductive bias in decision tree learning. So we'll see here the inductive bias in the decision tree learning algorithm. So what is the policy by which ID3 generalizes from observed training examples? So what is the policy by which it generalizes, classifies the data into the from of the training examples to classify the unseen instances? In other words, what is the its inductive bias? So what is the bias in the case of the decision tree? So ID3 search strategy select in favor of shorter tree over the longer one. So this is the inductive bias that is associated with the decision tree. So in the case of decision tree learning, we will select the shorter tree over the longer one, because as the label of the tree goes increases, complexity of the computation will also be increases. So we will there is an inductive bias in the case of decision tree, that we will favor shorter tree over the longer one. And another bias is that select tree that places the attribute with the highest information gain closest to the root. So we will again try to have the nodes and associated descendant nodes that having the highest information gain that will be closest to the root nodes. So approximate inductive bias of ID3 is that shorter tree are preferred over the larger tree. That is the basic inductive bias in the decision tree learning. So inductive bias of ID3 is thus a preference for certain hypotheses over the others, for certain hypotheses with no hard restriction on the hypothesis that can eventually enumerated. So this form of bias is typically called preference bias. So what even the technique, the bias has been discussed here. This is called the preference bias, because we are preferring one decision, one rule over the another rules. So preferences should be based on the some certain parameters, some certain decision. So the parameter could be that the shorter tree are preferred over the larger tree, longer tree, and the basic meaning of bias is that preferring one hypothesis with another hypothesis is called the bias. So bias meaning is that preferring one in respect to the another one, that is called the bias. So so here we are preferring the shorter tree over the larger tree. That's why there is bias. So inductive bias of the decision tree is that shorter tree are preferred over the larger tree. That is called the inductive bias in the decision tree learning. So what are the different issues in decision tree learning? First issue in decision tree learning is that overfitting the data. So given a hypothesis space H, so we have already given a hypothesis space H. If a hypothesis is said to overfit the training data, if there exists some alternative hypothesis, if there is some alternative hypothesis which is defined over the hypothesis space H, so such that H has a smaller error than H dash. If there are two hypotheses that is defined in hypothesis space capital H, so hypothesis H has a smaller, if hypothesis H has a smaller error than H dash over the training examples, but H dash, that means another hypothesis, second hypothesis has a smaller error than H over the entire distribution of example, over the entire distribution of instance, then that is called the overfitting the data. So this is the basic condition for overfitting the data. So hypothesis small h has the smaller error over the than H dash over the training example, but another hypothesis, second hypothesis S dash has the smaller error over the H than H over the entire distribution of instance, means in overall training data S dash has the smaller error, but in case of training data we have the smaller error than S dash, and S dash has the smaller error over the entire distribution of instance over the entire distribution of training data set. So that's why it is called as overfitting. So next issues in decision tree is guarding against bad attribute choices. The information gain measure has a bias that favors the attribute with many value over those with only a few. So this is again there is a bias that if an attribute having the more if an information gain measure has a bias that favors attributes with many values over those with only few. If an attribute having the few number of parameters, so that will be that will be not preferable over the attribute that having the more than one parameter, more than one value. So this is these are the issue in the decision tree. So next issues in decision tree learnings is handling continuous valued attributes. So note that continuous valued attributes can be partitioned into discrete number of disjoint intervals. So obviously we have the continuous valued attribute. So continuous valued attribute will be classified, will be splitted into decision node, into the sub nodes. So continuous valued attributes can be partitioned into the discrete number of disjoint intervals. Then we can test for membership to these intervals. So again we will be testing for the different attributes that will be belonging to those intervals. So these are the three different type of issues in decision tree learning. So I have discussed some issues in the case of the decision tree, that is overfitting the data. That is one of the most important things in case of the machine learning. Second one is guarding against bad attribute choices. So any attribute which having the less number of parameters will be not preferable over the other attribute which having the larger number of parameters. Again, there is the issue of handling continuous valued attribute. So continuous valued attribute can be partitioned into the discrete number of disjoint intervals. Then we can test for the membership up to those intervals. So we will classify again the we again in case of creation of decision tree, we will classify the different value nodes according to their interval value. So the value in this node had been created for interval 0 to 10, and this had been created for 10 to 20, this has been created for 20 to 30. So 20 to 30. So this again if we perform the classification, again we perform the splitting of the node. So again this will be created for 0 to 10 intervals, this will be again created for 10 to 20 intervals, this will be again created for 10, 20 to 30 intervals. So if decision is performed in such a way, so we will get here leaf node. So this is how the decision tree will be created based on certain parameter, that is called the decision, and thus will be performed at each and every descendant node of the decision tree. If there is no further splitting of the branch, if there are no further splitting or no further branching, then this particular node is said to be as leaf node, and that represents the final outcome of the decision tree. So in this particular lecture we will see up to this particular point. Then again further in next subsequent lectures we again see the next topic of the decision tree learning. So thank you.